Anyway, thanks for having me. I want to jump right into it. As DK said, I'm going to talk about a relatively new project called OpenHPC, and I thought I would give you some motivation and a little bit of brief history for this new effort. We have very recently set up some project governance, so I thought I would outline just at least from a high level who's involved, and then spend a little time talking about the stack and what we're trying to do, and end with just some quick information as to what's coming in the future. So in terms of motivation, for why I'm involved and why we were able to start this particular community effort, the motivation here is that a lot of the high-end sites, and as DK mentioned, I came from TAC, and so I certainly had experience doing this kind of thing, is that when we're deploying HPC systems, we're often reliant on a lot of open source software, including our favorite MVAPICH and other scientific software, and that we often are integrating this and maintaining that stack for many thousands of users potentially if you're at a big supercomputing site. And I think if we had our druthers, if we didn't have to do that, we'd probably say, great, if we could just get everything from the distro, our lives would probably be easier. But a lot of times the distro doesn't keep pace with the speed with which HPC software moves, and they also don't exactly target some of our use cases, right? Distros tend to operate much more in a mode where you just install one version of GCC, for example, in our world, we often have the need to install several different versions of GCC and other proprietary compilers and 3 or 4 different MPI stacks, and you end up with this sort of large permutation of software that you have to manage. And as a result, you tend to adopt some sort of system for your users so that they can access software, right? And a common one, at least in the HPC space, is the use of modules, the environment modules package. So the thought was, hey, if a lot of people are doing this, and is there an opportunity to try to, centralize some of this effort and see if some simple sort of, common conventions could be applied, and could we make, take some of the lessons that have been learned from the high-end centers and try to incorporate that into best practices and make prepackaged binaries available. So that's part of the OpenHPC effort. Of course, if you're going to make binaries available, you need to take on the role of doing some sort of validation and integration testing. So that's another important component that I'll tell you a little bit about what we're doing there. And finally, you can go sort of a couple of different ways, I think, if you're starting to put together an HPC stack. I'll tell you the way we went, which is that we didn't want to be super prescriptive on how to use the packages, right? And I'll show you in a little bit, really what we're standing up is a package repository for all intents and purposes. But we also want people to be able to have a recipe that they could follow, starting from bare metal to actually stand up an HPC cluster. But you have to decide, well, many people have their different pick for configuration management schemes, right? And if you pick one, you've just alienated the people who use different ones. So we are the thought here is that we would want to promote multiple system configuration recipes and essentially, provide those through OpenHPC and leverage reference designs and best practices, as I said, that come from the community. So, the top 3 is kind of what we've been starting to focus on. The bottom 2 bullets here are really motivation for future efforts. So we also, right now we're trying to just aggregate a lot of software that's pretty popular in use today. But we don't want this to just be a static kind of thing. We also want to use this as an avenue to promote new research, right? So as people are developing new runtime systems, for example, maybe it hasn't been widely adopted yet, but we want to make it as easy as possible from an integration perspective so that people could try out that software and provide feedback and hopefully promote faster adoption of new technology. And the final thing is that, as I mentioned, we don't really want to be super prescriptive on necessarily over time saying exactly what provisioning system you have to use or resource manager. So we do have an interest over time to try to develop interfaces between some of the key components that you see in HPC. And I threw out a couple of examples. So provisioning subsystems, resource management subsystems. You could imagine a scenario where if you wanted to dynamically provision your compute nodes as part of a user job, right? Say you're running Slurm and you just want to dynamically provision things, you can imagine that it might be convenient to have some abstraction around that, depending on whether you were using cobbler or werewolf or XCAT, something like that. So we're definitely not here yet, but I just wanted to set the stage for that is part of the motivation for setting up OpenHPC. All right, so in terms of history, so this kind of got started back at ISC in 2015, not OpenHPC, but I had a BOF there where we sort of tried to see if people might be interested in a community-supported HPC repository. And at the time, the discussion that we had there was trying to see, the usefulness of adopting what the distros do in terms of package managers, and most people seem to be in favor of that. We queried at the time what distros people were using, and at least the two most prominent, distros of interest seem to be CentOS and SLES. And when we queried about, look, is there enough momentum behind modules in HPC space that people would feel comfortable implementing that in a community repository? At least at that time, people were favorable. So we used that as input. I was here last year, and people may remember I snuck in a few comments about this as a sidebar to also see if people might be interested in it. That was good discussion. Adam actually put me in touch with someone at Livermore who's now also part of the community. And we followed that up with a BOF at supercomputing last year. And that's really when we had something that we could poke at. So we did an initial release of OpenHPC. Intel sort of seeded the effort with a 1.0 release. But we, at that time, got a lot of community interest and made the decision that we'd like to go and formalize that through the Linux Foundation. And basically, since supercomputing last year, that's kind of what we worked on from November to May. And right before ISC this summer, the Linux Foundation announced that we were up and running, we were a collaborative group, and that we had an initial governance structure, which I'll tell you. So that's kind of the brief history of the project. In terms of participating members, it's just this token logo slide of everybody who's participating at the moment. There's roughly, I think, 25-ish different institutions here and organizations. The thing to walk away with is that it's a mixture of academia, national labs, some OEMs, and ISVs and OSVs. So, now we are running everything through the Linux Foundation. The gentleman here, Jeff Ernst Friedman, for anybody who might be interested, they'd be happy to walk through the process. And I will just say one of the things that was very important, at least for me, coming from an academic background, just to let folks know, is I felt it's very important if you're going to stand up a community like this that you don't want to make it difficult for labs and universities to join. So in terms of joining, if someone was interested to join OpenHPC with the Linux Foundation, there's no cost associated with it for academics or lab members. There is some membership fees associated if you come from a commercial background. All right, so I mentioned that we were just formalized with the Linux Foundation, and so we do have a governance structure, and I just briefly want to show you kind of how that's made out. Very, very high level. So there's two primary organizations in OpenHPC. There's a governing board, which we show on the left-hand side, and then there's a technical steering committee. And from our perspective, the kinds of folks who are here, we primarily care about the technical project leadership, and we did try to make OpenHPC as technically oriented as possible, and sort of segment off the technical direction in this technical steering committee. They're the folks who are really responsible for doing the day-to-day work and doing releases. We do need to have a governing board, though, because there is budget associated with the project and marketing, that kind of stuff. So, but you can sort of see the high-level delineation. In terms of the technical steering committee, which I think is perhaps the most interesting part for this party, we do have roles from, we've defined several different roles within the technical steering committee because we want to have input from a variety of people's point of view. So the main thing to point out is that we do have representation from people who are upstream component developers, and by this I mean people who, in the MVAPICH group would be a good example here, right? They're developing MVAPICH. They have certain constraints, if people are going to use, pre-built binaries downstream. So, people who are actively engaged in R&D development, those are the people in the upstream component development representatives. And then the converse to that is we have people who maybe they're not doing software development, but they're at a supercomputing site, and they're standing up systems and having to support lots of different users, right? So they really are an end-user side representative, and we've tried to sort of capture the extreme where possible of those 2 points of view. And then of course we have maintainers. That's really following the distro model where people are responsible for the packaging and the integration and the testing of things before they go out. And just to, you'll have these when they get posted, not to go over everybody's name here, but just to point out there's roughly 20 people who have volunteered to serve on the technical steering committee, and the reason I'm here is I'm volunteering as the initial project lead for the project. Okay, so that's a bit of motivation and history and a couple of words about the governance. Now I'd like to tell you a little bit about the stack and what we have today. So initially this has primarily been a packaging effort, and it's a packaging effort with HPC in mind. And so we are, I already mentioned the fact that we sort of settled on the use of modules. So in our case, we are using the version of modules that comes from LMOD, which developed at TAC, and we're embedding that into all of our packaging efforts. We're also endeavoring to provide hierarchical development environment, and I'll go over this a little bit more, but this is acknowledging the fact right up front that in the HPC space we have multiple compilers and multiple MPI stacks, and that often permeates all the way down through every library that we build. So trying to deal with that up front. Our intent here is to really provide building blocks, and because they're building blocks, we are trying to take on the onus of managing package dependencies. So again, that very much follows the distro model, where if you install a particular bit of software and you don't have the sub-dependency, that you'll install that at the same time. And the reason I point this out, I was speaking with folks yesterday, the point here is that OpenHPC, and I'll show you all the packages that are there in a second, but we're trying to provide something so that people can go from end to end to install a system, but it really is just building blocks. So if you don't like the provisioner that happens to be in OpenHPC today, no harm, no foul. You could still pick and choose some of the development libraries and implement them within your own provisioning system. And so that's really what I harken back to the fact that we don't want to be too prescriptive as to how to use it. So we try to put a lot of effort into the packaging of the building blocks themselves. So as an example, as of a package that's available, PETC is very commonly used in the scientific community. And PETC is something that requires MPI, and you can kind of get a feel of the hierarchy in our packaging right now, where if you enabled the OpenHPC repo, you'd be able to install a version of PETC that was built with GCC and MVAPICH 2, for example. And we are trying to provide some common conventions for environment variables and the modules. So once an administrator installed this package, the end user could do their usual business, module load PETC, access some common environment variables, and go to town. So all of the development libraries tend to operate just like that. Here's a quick summary of the components that are in sort of the most recent release of OpenHPC. I list base OS here as a component. Now, to be fair, that's not something that OpenHPC is providing, right? The assumption, the use model today assumes that you install a compatible base operating system, and then you would have access to all of these other things. So I just point here that the two base OSs that we've been building against thus far are CentOS 7 and SLES 12. So then we sort of group everything else in a variety of functional areas. So the top things tend to be a little more administrative oriented. Tools for the administrator for monitoring the system, monitoring Lustre if they happen to be using Lustre. At the moment, we do just have one provisioning system, and we're using Werewolf today out of Lawrence Berkeley. That is a system that can do sort of both stateful and stateless provisioning. But as I said, over time, I expect that this will grow to have multiple provisioning systems, and the packages that are available they're not dependent on Werewolf. We're just using Werewolf to provide bare metal capability. Resource manager today is firm. Again, that's another area where I would expect we'll have recipes that have multiple resource managers. And if you happen to pay attention to the people who are involved, you'll notice that Altair is one of the members. So of course they're interested in having their open source resource manager included. Now if you're a seasoned veteran like Adam here, you might go, well, this is a very tiny list. It's nice, but it's it's not everything you need, and I wholeheartedly agree, right? But I think it's certainly a lot of the common stuff that if you're standing up a general purpose HPC system that your users are probably going to ask for, right? Boost and FFTW and Metis and Cholinos and all those kinds of things. And same for some of the performance analysis tools. I know Samir's here, and so things like Tau and their leverage of PAPI and those kinds of common open source tools. So hopefully we've at least picked the floor of the minimum, and over time hope to grow this. So today there's roughly I think 270 RPMs, and we're building each of these for a variety of compiler and MPI families. So for something that is a library that has an MPI requirement, today we build 6 different permutations of that. Now, I did highlight, I heard Adam went strong yesterday with the Olympic reference, so I of course tried to highlight that the most important one here is MVAPICH 2, and that gets us the Usain Bolt of MPI, I guess, for OpenHPC. So that's my Olympic contribution. It looks pretty good, Dom. It's almost natural. Just sort of highlighting this hierarchical business, beating it to death. I think if you've been standing up big systems, you probably, you might have adopted something like this. It's certainly common. But this is just pointing out that, we have some tools which are administrative. We just build those with, the distro GCC. But things that end up being exposed to the user for their development environment, right? Like I/O libraries. The instant anything has a Fortran interface, you sort of get sucked into building the thing many, many times. And so we just sort of say, yep, that's how it is in HPC. We're just going to own that. We magnify that when it has a requirement for MPI. So as an example, the Boost library and the parallel HDF5 library that you would see in OpenHPC, they have 6 different variants. And we just call that out. I'll say a little bit more about how we try to abstract that in the build system here coming forward. But you would see all of these RPMs defined. So I thought I would just, from a very high level, walk through, if you were to download the sort of recipe guide today and start from scratch, and you wanted to do a bare metal install, just the 3 steps that you would sort of follow. So as I mentioned today, we don't distribute a base OS. We assume that's not our business. The distros do a good job of that. So the assumption is that if you were starting and had nothing, you would install a base OS on one master node. So that would be sort of step 1. That's just following the distro, right? If it was CentOS, you start from their ISO. If it was SUSE, you start with the SLES ISO. Then at that point, you would be in a position to start to pick and choose different packages from OpenHPC. So this is a case where we're not trying to reinvent the wheel here. We're essentially following what the distro people do. So the same way you might enable CentOS, we're providing, or Apple, we're providing a package called OHPC release that you could download, and that just enables a network repository. Okay? So at that point, you would then be able to start to request different things. And so if you install this OHPC release business, what you would see, again, stealing directly from the way CentOS works, you would actually enable 2 different repos, a base repository and an update repository. And the idea here is that for a given tree, where possible, we want to make it as easy for people as bugs fixes come out and new versions of software we make available. We want to go ahead and pre-populate their repo so that they can get updates and just do yum update over time or zipper update, the equivalent in whichever OS you're using. So you now have your repos installed. Then you go about picking and choosing what you want. So if you were to look, we have one recipe that starts from scratch today, and since you're starting from scratch, it does need to enable provisioning, and it enables a resource manager. So one of the things that we try to do is provide some convenience aliases. And aliases in this world maps to the package manager as groups. Okay, so you can see here some examples of installing some base packages, requirements that would be needed on any system. And then because we're using Werewolf, as opposed to telling you to install 12 different RPMs of Werewolf, we just wrap it all up into a group called OHPC Werewolf, right? And the same kind of thing is applied here for major subsystems. So the resource manager, we have a group that is for the server side of Slurm and then the client side of Slurm to sort of differentiate those things. So if you were to follow our recipe, there'd be an awful lot of young commands like this. And then there would be optional stuff that might say, hey, are you enabling Lustre on InfiniBand? Well, that means you need to enable IP over IP, and you're going to have to set that up. And so we provide an example ifconfig file for IB, just so that you have a starting place, and kind of walk you through setting it up based on IP settings that you might have locally on your machine. So I will point out that this is not the push the easy button and just walk away and magically have everything happen. Today, because it's building block oriented and we want to be very transparent, this recipe is purposely like very transparent on editing a particular file and showing you what to do, because you may want to put that under config management and do it some other way. All right. So I mentioned there's a lot of commands that to pick and choose different software. So if you were to follow this, you would see there would be a lot of cutting and pasting if you just wanted to exactly replicate the guide. And I mentioned the importance of validation for the project. We really would like to have people to have confidence that if they got these packages and they followed the directions, that it would work end to end and they would have a nice capable environment on their system. So we put a fair bit of work into doing integration testing, and we need that to be automated. Obviously, I'll tell you the tools we're using. But because you're not going to automate cutting and pasting from a PDF, right? What we have done is we essentially, all the commands that are instantiated in our documentation, they, at the end of the day, they get made available in a bash script. So, and that bash script is essentially has all the commands that we would run in our example recipe, and that's what we use in the validation process. So we just made that available in an RPM as well, which is docs-ohpc, so that if you wanted to use that as a starting point for customizing your own configuration, you'd have that, and you wouldn't have to bother with retyping anything. All right, so that's pretty much the process. If you followed that, in theory, you have a working cluster at the end. So I wanted to say a little bit about the development infrastructure. So what are we using to do all this? Well, it's most of the standard kinds of stuff and little things that might be a little bit different than what we traditionally use in HPC. So in terms of all the source code, that's GitHub. That's ubiquitous at this point. In terms of our continuous integration environment, we're using Jenkins. And for the documentation stuff, for reasons so that we can automate, that's all written in LaTeX. Probably the most interesting bit to this crowd, for people who are involved in packaging software, is what we're using to do the build itself. So we're using something called the Open Build service. That is an open source project that comes out of OpenSUSE. That's actually what they use to build OpenSUSE and manage their distributions. And at the end of the day, and so our Open Build service is at this URL. And at the end of the day, we're delivering RPMs, and I already pointed out that there was a base and an update repository, and we're using OBS to drive our builds and then to publish these repos. So if you go and you install the OHPC release business, essentially what you would be pointing at is a repo that OBS created for us. And the reason that we looked into using a tool like this is we wanted to be able to support multiple distros. Right, and so you saw, I mentioned we have CentOS and SLES today, and at least ideally the notion of maybe also doing something that isn't RPM based, right? And so we don't have that today. Everything we are publishing RPMs, but OBS, in theory, can take a spec file and also generate Debian packages, right? So we like the idea of being able to have one input really generate different types of packages for different package managers unique to distros of interest. So we have engineered our system using OBS. Everything in terms of the spec files, so really our infrastructure for integration is about creating spec files, and I'll show you some snippets in a second. But all of that stuff is what you would see in GitHub, and OBS is really in charge of sucking stuff in from commits to GitHub and performing automated builds and doing dependency analysis. Right? So that's just a quick snapshot of what the OBS page looks like. You would never necessarily come here, you would just enable a repo, but this is what's doing the work. And the main thing also to highlight is that it gives us a place to do repeatable builds, right? It's very transparent. It just takes spec files and it generates binary and source RPMs. So again, the end user, if they don't like the way something is done, they can download the source RPM and go to town. And another nice thing about it is it happens to be a distributed, client-server type of implementation. So we're in the process now of actually standing up some infrastructure where build systems will be remotely located. So this build system is on the cloud, on EC2, but we're standing up some infrastructure at TAC that's going to host some CI infrastructure and build infrastructure. So we're kind of leveraging that capability in OBS. So just to peel back a little bit, the how we do the builds themselves. So I mentioned, spec files are really the input here, and we do want to provide some level of some conventions across all of the package. So just about every spec file that you would see in OpenMPI today is going to include a macro file called OHPC macros. And sorry, if you're not an RPM person, I apologize in advance, but for those who are, I thought they might be interested in this stuff. So essentially, here's where we try to abstract, the hierarchy of where we're going to install different software. So, the top level, you can see basically, in our case, maps to OptoHPC. If you don't like that, you have a source RPM, you could change it very easily. And we essentially, then tree off of that to do lots of other different installation paths. So, applications we tend to put in one space, libraries we tend to put in a top level directory as well. Same for compilers and MPI stacks. So this sets sort of our installation targets. And then, the other bit of magic, if there is magic here, is that we have all these libraries that depend on MPI. So, and we mentioned that we're building environment modules for them, so we might as well use those in the RPM build process itself. So the other thing that you would see if you looked at PETSI, for example, you would see that it's going to include macro information from this file, OHPC setup MPI, and this is basically just the logic which says, hey, how to set up an environment to do an MVAPICH build or an OpenMPI build. And you do the exact same thing that an end user would do on your site. We just incorporate that directly into the build system, right? So right there, you can see the three that we have supported today would be MVAPICH, OpenMPI, and Intel MPI. All right. Now, I mentioned we want to have sort of a single input driving lots of different builds, and that makes your spec files start to get more complicated. But that's okay. We have templates to try to help with that. So this is just a snippet of the spec file from Metis, which, not par Metis, so this is just Metis, so it doesn't need MPI. But you'll see, kind of the convention here. So what we tend to do is we say, hey, by default, unless you're overriding, we're assuming you're going to build with the GCC compiler, right? And that's this compiler family of GNU, all right? But you can override that. And I'll show you a cute little trick we do in OBS to override it. But then you just manage all the dependencies directly in the spec file, right? And if you're doing GCC, well, then you need the GCC compilers. And if you're doing Intel, then you need those compilers. And you can imagine putting PGI, whatever you want here, and just having this logic grow and grow. And this, basically gets us the logic for managing the package dependencies. Now, in terms of how we actually set the things like the compiler family and the MPI family, this is where we're taking advantage of a pretty cute option in OBS, which is essentially you can link different packages within OBS, right? So here again is an example from Metis, and what I'm showing you now the OBS side of things, which most people aren't going to mess with, but it's interesting to see the logic. So there's essentially one parent, and in our case, if it's a package that has a compiler family, then we would have one child, right, for Intel. If it was an MPI package, we would have 5 children, right? And so this service thing tells OBS how to go connect to GitHub, how to download the source tarball, all that kind of stuff. But the cute thing is that to create a subsequent build that is going to enable Intel, what we do is we have this link file, and essentially we just define this compiler family variable that I just showed on the previous slide, and when it concatenates and creates a spec file, this macro definition is in there. And so then at the end, what we get out of this is the way we've hooked it all up is if a user checks in a commit to metis.spec, right? Maybe they change the version, it automatically kicks off both builds, all driven from one input, which we like. Real fast on integration testing, just want to point out that we do a fair bit of integration testing here, not trying to validate the good work that the upstream people are doing. We know that when DK and team release MVAPICH, In the history of MVAPICH, there's never been one bug, so we never worry about that. But what we worry about is, did we screw it up, right? Did the build process screw it up? Did our subdependencies of all these other libraries, there's a million places to go wrong, and maybe we didn't even install what we needed on a compute node, right? There's all kinds of places to go wrong. So what we're really looking for is the cross-pollination between these different components. And just to kind of show you, what we have. So we've created a test harness. This test harness is also part of the OpenHPC project, and you would see it on GitHub. But it's essentially trying to provide simple, kick the tires kind of tests on every library that's included. So you'll notice, these packages that were listed in the manifest of software that is being packaged for OpenHPC. For every single one of those, we have a corresponding test. And for things that have a compiler or an MPI dependency, you can imagine we abstract that and loop over every permutation and test every one, right? So that we can make sure that PETSI works with every possible combination of MPI and the compiler. And this takes roughly a couple hours to run. There's something like 1,800 tests now. I just want to mention it that as we add more components, the expectation is that to find your way into OpenHPC, we're going to have to add a test every time as well, so that people have confidence.
How many nodes you are running for those previous tests?
The assumption here actually is, because it's a CI environment, it's actually a pretty small number of nodes, because these really are, is it working? At the moment, they're not performance oriented, so it might only be 16 nodes, for example. But that's partially also due to the amount of hardware that we have. So we're going to be making available roughly 24, 25 nodes at TAD just dedicated doing this. But you think about, you want to test CentOS and SLES and every commit, right? And so it tends to be lots of small clusters dynamically.
How long will it take me
to run? We have a short and a long version. I'm not going to go into that. So the short, we try to do basically, we try to keep that under 20 minutes. So that actually disables a lot of the tests. Short tests to make sure things like MPI work. Because if MPI doesn't work, everything else is busted. But long is what you see here, where everything gets turned on. And these days, that's about 2.5 hours. Yeah. And since I'm at the end, I just finish with kind of what's coming from the OpenHPC project point of view. The thing we've been discussing the most, the question I get the most, is how do we get more software into OpenHPC? So we're trying to formalize what a component selection process would look like, so that we can sort of advertise that to the community and start getting more software in, and establishing expectations around integration testing, packaging conventions, being able to publish a timeline in the future. And I've already alluded to the fact that we are standing up some public CI infrastructure. I will tell you that everything, the packaging that we have today, the releases that we have today are for x86. But ARM is also part of the project, and we're starting to set up infrastructure as well for ARM to have ARM builds, and the intent will be to have a companion recipe that works end-to-end for ARM as well. So I'm at the end of my time, or slightly over. Thank you very much. I'll apologize that I have to head out pretty quick, but I put my email here in case anybody wants to throw tomatoes at me afterwards. So thank you.